Case study: AI in cybersecurity, navigating challenges and advancing defenses in a complex digital landscape. The stakes were high as Emily Chen, the Chief Information Security Officer of a large multinational corporation, found herself grappling with an unprecedented cyber attack. The company had recently integrated an advanced AI-based cybersecurity system to bolster its defenses, and Emily was confident in its capabilities. However, the current situation tested everything she understood about the synergy between AI and cybersecurity. The attack began subtly, a minor anomaly in network traffic picked up by their intrusion detection system. Emily quickly convened her team in the war room, where the walls were lined with monitors displaying real-time data. They faced a sophisticated adversary, using advanced techniques to mask their presence. The team had to determine if their AI system was up to the task and what steps they should take next. The AI system flagged multiple activities as potential threats, prompting Emily to question its accuracy. "How reliable are these alerts?" she asked, glancing at her lead data scientist, Dr. Tom Parker. Dr. Parker explained that the system used machine learning algorithms trained on historical data to detect anomalies. However, he acknowledged that false positives were a known issue. This prompted Emily to wonder, what balance should we strike between sensitivity and specificity to ensure we detect actual threats without overwhelming the team with false alarms? As they delved deeper, the AI system identified a pattern, an unusual volume of outbound data traffic. This raised alarms about a potential data exfiltration. The attackers seemed to be using AI to adapt their tactics in real time, making it challenging for the team to respond swiftly. Emily pondered, how can we leverage AI's predictive capabilities to anticipate and counter such adaptive threats? Reflecting on the historical context of AI in cybersecurity, Emily realized the importance of understanding how AI had evolved to address new challenges. During the early days of AI development in the 1950s and 1960s, pioneers like Alan Turing and John McCarthy had laid the foundational concepts. But back then, the focus was more on developing the core principles of AI rather than applying it to cybersecurity. The field of cybersecurity was simultaneously evolving, driven by the need to protect sensitive information, especially in military and governmental contexts. Fast forward to the 1970s and 1980s, AI witnessed significant advancements with the development of expert systems designed to replicate human decision-making. At the same time, the ARPANET, a precursor to the modern internet, faced its first cyber threats, highlighting the vulnerability of computer networks and spurring advancements in cybersecurity protocols. These early systems laid the groundwork for the integration of AI into cybersecurity solutions. As the 1990s ushered in the digital revolution, the proliferation of personal computers and the internet led to an increase in cyber threats like viruses and worms. Intrusion detection systems emerged, utilizing AI to differentiate between normal and malicious activities. Emily thought about how her current AI system built on these innovations to provide real-time threat detection and response. In the early 2000s, the rise of big data offered AI vast amounts of information to analyze, enhancing the accuracy of machine learning models. This period also saw the emergence of advanced persistent threats and sophisticated malware, necessitating proactive cybersecurity measures. Emily's AI system represented this shift towards predictive analytics, anticipating potential attacks based on historical data. By the 2010s, deep learning, a subset of machine learning, revolutionized pattern recognition and data analysis. Deep learning algorithms could process large datasets and identify intricate patterns, which was particularly beneficial for detecting subtle anomalies in cybersecurity. Emily's AI system utilized these advancements to identify deviations in user behavior that might indicate a compromised account. Despite its capabilities, the integration of AI in cybersecurity came with challenges. Emily knew that attackers were also leveraging AI to develop more sophisticated and adaptive malware. This adversarial nature of AI created an arms race between cyber attackers and defenders. How can we stay ahead in this ongoing battle where both sides are using AI to gain an advantage? Emily asked her team. Another concern was the potential for false positives and false negatives. An overly sensitive system could disrupt normal operations by flagging benign activities as threats, while an insufficiently sensitive system might fail to detect actual threats. This required continuous refinement of AI models to maintain a balance between security and usability. In recent years, the concept of explainable AI gained traction, aiming to make AI decisions more transparent and understandable to human operators. Emily appreciated the importance of XAI in helping her team understand the rationale behind AI-generated alerts, aiding in making informed decisions. How can we ensure our AI systems' decisions are transparent and understandable to enhance our overall security posture? She wondered. Emily also recognized the need for collaboration between academia, industry, and government to advance AI technologies and explore their applications in cybersecurity. Academic research had been instrumental in these advancements, while industry partnerships facilitated the development and large-scale deployment of AI-driven security solutions. Government initiatives and regulations provided a framework for ensuring the ethical use of AI in cybersecurity. Reflecting on this, Emily considered, how can we foster better collaboration between these sectors to enhance our cybersecurity measures? Looking ahead, Emily knew the future of AI in cybersecurity appeared promising. The increasing adoption of the Internet of Things and the growing complexity of cyber threats would necessitate more sophisticated AI-driven security solutions. The development of quantum computing posed both opportunities and challenges, as quantum computers could break traditional encryption methods, but also offered new possibilities for creating unbreakable encryption techniques. Emily wondered, how should we prepare for the impact of quantum computing on our AI-driven cybersecurity measures? In the end, the team managed to thwart the attack, but the experience left Emily with valuable insights. The historical context of AI in cybersecurity illustrated a dynamic and evolving relationship that significantly influenced their approach to digital security. From the early days of computing to the present, understanding this evolution helped Emily and her team appreciate the importance of continuous research, collaboration, and innovation to stay ahead of potential threats. Addressing the thought-provoking questions raised during the incident, Emily and her team conducted a detailed analysis and devised solutions. They decided to fine-tune their AI system's sensitivity to strike a balance between detecting actual threats and avoiding false positives. By leveraging AI's predictive capabilities, they aimed to anticipate and counter adaptive threats more effectively. Emphasizing the importance of explainable AI, they ensured the system's decisions were transparent and understandable, aiding in informed decision-making. Recognizing the adversarial nature of AI, they committed to staying ahead in the ongoing battle by continuously refining their models and algorithms. Collaboration between academia, industry, and government was identified as crucial, and they actively sought partnerships to enhance their cybersecurity measures. Finally, they prepared for the impact of quantum computing by exploring new encryption techniques and staying informed about advancements in the field. In conclusion, Emily's experience underscored the transformative role of AI in cybersecurity and the need for ongoing research and collaboration. The dynamic relationship between AI and cybersecurity had shaped their approach to digital security, enabling more effective threat detection and response. By leveraging AI's capabilities and addressing its challenges, Emily and her team aimed to stay ahead of evolving cyber threats, ensuring their organization remained secure in an increasingly complex digital landscape.